So let us see this problem of solid. So in this given, a hexagonal pyramid, side of base 30 mm and height, that means the axis height is 55 mm, lies on one of its triangular faces on HP. Draw its three views. So we have to draw its three views. Fine. So the solid is a hexagonal pyramid. Base edge is given 30 mm and axis height is given 55 mm. Condition is that it is lying on one of its triangular faces. So first we'll have to make it stand on the ground. This will be the first step, and second step is we have to make it lie on the ground. So that means for the first step, when we are making it stand on the ground, so from the top view I'll be able to see the true shape of the base, and in the front view you will be able to see the axis height. So let us begin with the problem. So first we draw the reference line, and this time we will draw the reference line a bit longer because we have to as well draw the left hand side view. We have to draw its three views, it is mentioned, right? So as if first we have to make it stand on the ground, right, and then we have to tilt it so that it lies on the ground in this fashion. So when we are making it lie on a triangular face, that means we want the triangular face to be perpendicular to the XY line. So that means top view of hexagon will come out like this, right? So the base edge is given 30. So first we'll take 30 mm in our compass. Right, and we draw a construction circle. So this is the reference line XY. Now we want the the hexagon to be like this. That means I want two opposite parallel base edges to be perpendicular to XY. So that is why the first 2 points what we are going to consider or select will be the 2 points perpendicular to XY line, right? So we know how to draw a hexagon. Then we take the same radius in compass as side. So we get these two base corners, then these two base corners. So we join them. So we get the base now this is a pyramid. That means all these slant faces will be coming and meeting at the apex. So here that means we need to draw all the diagonals for this hexagon. So now if you see, you will get the effect of a pyramid. So this is the apex of the solid. So I name the apex as O. These are the base corners A, B, C, D, E and F. So now we project it for the front view. So the base will be on the XY line and this as the axis, right? And height of the axis is given to me as 55 mm. So I measure 55 and I mark it. So I get the front view of the apex. So we get the front view of the solid as an isosceles triangle. Right, so let us name it. So we are looking at it in this direction. So this is A dash B dash, this is F dash C dash, and this is E dash D dash, this is O dash, and this OF slant height will be visible in the front view. This is exposed to the observer So we get this as the solid line. So now we will make it lie on the ground. So that means apex O will come on the ground and the base edge ED will be on the ground. So the face edge OED is on the ground. So we are making it lie on the ground. So for that, we move on to the next step. So first I mark one point. So this is say E1 dash, D1 dash. So it will be the same triangle we will be able to see. So we take this length in compass, right? E1, D1 as center, and I mark it. So we get O1 dash. So this side of the triangle and this is same because this is isosceles triangle. So we are reproducing the same triangle. So I take this base in compass now, E1, D1 as center, and I mark it. So when we are making it lie, so A and B are going to get lifted up. So this point is A1 dash, B1 dash. So we have reproduced this same triangle and the solid is now lying on the ground, and we have to mark FC. So this is F1C1. So this is F1 dash C1 dash. So now we drop the projectors for the top view. So I drop the projectors from all the base corners, right, and the apex. Then we drag all the corners or the loci of the corners to get the top view in this condition. So these are the base corners being, this is the apex, there are the two bases, and right. So projector of O, locus of O, we get this as O1. Now this is projector of A, projector of locus of A. So this is A1, right? Locus of B, projector of B. So this is B1. Locus of C, projector of C, C1. Projector of D, locus of D. So this is D1. And this is E1 and this is F1, right? Then the first step to get the view or the projection will be joining all the peripheral points by solid lines. So we join all the peripheral points with the help of solid lines. So this will be always the first step whenever we are going for projection of solid, joining all the peripheral points. Second step is to draw the base. So this is a top view. That means we are looking at this solid from the top. So base is exposed. That means all the base edges are visible. So all base edges will be solid. So AB, BC, CD, DE and EF. So out of which CD, DE and EF are done in the first step, the remaining are AB, BC and AF. Now when we are looking at it from the top, so this AB is visible, this face is visible, OAB, this triangular face is completely visible. So OB1A, that will be a, so OB and OA will be solid. Now you will see that the face OED is at the bottom of the solid. So it is covered by the solid. That means OE and OD, they are hidden. So OD and OE will be dotted lines. So we represent the hidden edges with the help of dotted lines. So here we get the projection of the solid in this condition, right? Now finally we have to draw 3 views. So for 3 views, then I'll have to go for the profile view or the left hand side view. So for that, first I draw the new reference line x1 y1 perpendicular to the xy. So this is x1 y1. So to get the left hand side view, we will drag all the loci from the top view, rotate it and project it, and from the front view we will get the height of all the corners. So let us first project them or drag these loci of all the corners till the x1 y1. Then intersection of xy and x1 y1 is the origin. So about this we will rotate all these loci. So this is locus of apex, which was missed. So now O as center, this origin as center. So now we rotate all these loci till xy from the intersection of x1 y1 and xy. Right, and we will project them for the left hand side view. So this and this, right? So we are drawing the left hand side view. That means we are looking at the solid. For this view we are looking at the solid from this direction, from the left, and we are looking in this direction. So now we will drag all the heights for the front view. So parallel to xy. So O, D and E are done. This is F and C, and this is A and B, right? So let us see. So this is projector for O. This is height of O. So this is O1 double dash. Then E and D, their height is also 0. So let us see. So this is E. So this is E1 double dash. This is D. So this is D1 double dash, right? Then C. So this is C. So this is C1 double dash. This is F. So height of F. So this is F1 double dash. Then this is B. So this is B1 double dash, and this is A1 double dash, right? So now we join. Again we will follow the same rule. First we will join all the peripheral points. So we join all the peripheral points. So it's obvious when you are standing here, the entire base is visible and the apex is hidden behind the base, right? So we get D, right? And now we have to draw the face edges, that is OA, OB, OC, OD and OF, right? Now here in this case it's quite easy to understand. All these face edges are behind the base. So all the face edges are dotted. So OA will be dotted, OB is dotted, OC is dotted, and OF is also dotted. So thus we finish the base is visible and all the face edges are hidden behind the base. So that is all in this problem.